commuting. A man who moves to a new city sees that there are two routes he can take to work. A neighbor who has lived there a long time tells him that Route A will average 5 minutes faster than Route B. The man decides to experiment. Each day he flips a coin to determine which way to go, driving each route 20 days. He finds that Route A takes an average of 40 minutes with standard deviation 3, and Route B takes an average of 43 minutes with standard deviation 2. Histograms of travel times show that the routes are roughly symmetric and show no outliers. So A says find a 95% confidence interval for the difference in average commuting time for the two routes. So we've got Route A, and we had an average of 40 minutes. So y bar for Route A is 40 minutes, and the standard deviation of Route A is 3 minutes. And for Route B, the sample mean of Route B was 43 minutes, and the standard deviation of Route B was 2 minutes. And he drove each route 20 days. So size n for group 1, or group A, is 20, and then size n of group B is also 20. And we want to find a 95% confidence interval for the difference, mu A minus mu B. So it's going to be the sample mean of group 1 minus the sample mean of group 2. This is our observed difference, plus or minus our critical value, times our standard error. So our standard error is S1 squared over N1, or I'm using A because it's group A, and then S2 squared, or in this case, it's group B, S of group B squared over N2. All right, so our critical value, we got to figure out what this is. In this case, we're going to use degrees of freedom is equal to N1 or plus N2 minus 2. So in this case, we have 20 in group 1, or plus 20 in group B, minus 2. So that gives me 38 degrees of freedom. And we're looking for a 95% confidence interval. So I don't see 38 degrees of freedom, but I've got 35 degrees of freedom. So for 95% confidence interval and 35 degrees of freedom, my critical value is 2.030. Okay. So let me just put down 2.030, and I'm going to plug in all of the numbers that I have. So group A's mean is 40, group B's mean is 43. So 40 minus 43 plus or minus 2.030 divided by square root of SA squared. So 3 squared divided by 20 plus 2 squared divided by 20. So I have negative 3 plus or minus. So I have 3 squared divided by 20 plus 2 squared divided by 20. The square root of that times 2.030. So I have negative 3 plus or minus 1.637. So I have negative 3 minus 1.637. And on the lower end, I get negative 4.637. And on the upper end, negative 1.363. Okay, so this says I am 95% confident that that the mean time of Route A is between 4.6 and 1.4 minutes shorter than the mean of Route B. All right, so part B asks us Should the man believe the old-timer's claim that he can save an average of 5 minutes a day by always driving Route A? So it is true that Route A is shorter, that we have evidence that Route A is shorter than Route B, but it's not. But 5 minutes, a 5-minute savings is not within our 95% confidence interval, so no, he should not believe he will save 5 minutes. 5 minutes on the trip.